Let me introduce myself. I am Sharvan Kumar and I have 17 years of experience as a solution architect and AI builder. So in the next couple of slides, I will explain to you the engineering behind a chatbot. So the very first image says it all. So basically what you're seeing is a big pipeline where we have a raw Babel in the form of unstructured data, nodes, books, and then we have a couple of nodes, and finally we have an output which is brilliance conversational and which is human-centric. What we are seeing is a pipeline having first node as a data forging where we are fetching the raw data and then raw materials as a raw material, and then we are putting it to our pipeline. Then we have algorithmic refinement. Algorithmic refinement is the place where the model actually runs. And finally, node 3, which is a quality assurance of the human safety checks. So chatbot is not just a one thing, it is a big pipeline. So the key insight is chatbot is not just a one thing, it is a pipeline where each stage has a specific job to do, and skipping a single stage can deliver a broken product. Let us walk through the each stages. So before proceeding further, I want you to carry this mental model. Building a chatbot has three stages, visualized as here as a circle. Consider the first stage as your model is like a child, where it has been provided as all kind of books in the world and all kind of knowledge. Step 2 is where it acts as a student, it goes to school, learns how to question and answer from the experts. And step 3 is your human feedback reinforcement learning, where it knows what is good, what is bad, what is safe, what is polite, what is helpful, all human values. And then we have a guardrail surrounding for all the safety wrapping up in the brain. So guardrail is basically a safety chakra which is wrapped up around the model, which basically takes care of all the bad inputs and it does not let it reach to the model. So this is a very important step, preparing the data, where we have a massive web data from the websites, code, books, and it is an industrial pipeline through which it goes, where first of all the HTML tags, ads, etc. are stripped. Then we have a filtering of spam, low quality text. Then it removes the personally identifiable information to avoid any legal issues. And then there is a deduplication because there are multiple articles on the same topic available around the web. Then finally we have the clean tokens through which a model can run. For example, to give you a context, Meta's LLM1 ingested 1.4 trillion tokens with 67% surviving from heavily filtered web crawls. So now one of the big problem which the AI encounters is, and this sounds very technical, but it is actually very beautiful and easy to understand. So the bigger challenge for the model is to understand the context of a long conversation without losing track of how words relate to each other. So now for that we have two mechanisms, absolute positioning and rotatory positioning encoding. So as far as the absolute positioning is concerned, it is like numbering each word at a particular position and then using it. But for a larger context or larger chain of words, it is very difficult to track. For the solution of it is rotary positional encoding. And what actually happens here is it assume it there is a kind of big compass, and dog and cat are placed based on their embeddings. We convert it into a number and put it somewhere on this compass. Now there is a angle between them which remains fixed. So if you look at the timeline A, the cat chased the dog. Cat and dog are at a different position. And the timeline B, once upon at a time, the cat chased the dog. Or again, the cat and dog are at a different position, but the angle between them and their relationship is preserved. So AI does not care about the absolute positioning, it cares about the relationship. And by encoding it, you can go up to any length, and the context and the relative position will remain. And this is the reason which why you would have observed that the recent models can go up to 100,000 or millions of tokens. Now we enter the model development phase. The number first type age is pre-training the babbler, and this is basically what generates the base model, which has an understanding and knowledge of all the world, which is a general purpose model, and it is a very costly affair. It is done periodically, and the purpose here is that the base model should be able to predict the next token uh, by guessing the next word in billions of sentences. This requires thousands of GPUs and months of time. And finally, what we get is a model that understands the language, but it cannot hold a conversation. So the next stage is supervised fine-tuning. And here it is basically, it's not the quantity, but the quality matters. So now the base model is specifically trained with tens of thousands of base prompts and responses. And this demonstration data is prepared by, some of the best of the minds. For example, OpenAI hired all the master degree experts to label their data. So basically, what we are having in this stage is a quality data, and that teaches the model what kind of questions will come and how to respond to them. For example, if the question of the user is I want to learn programming, the SFT model will respond that start with Python. It is beginner friendly and widely used in the industry. So SFT model is like a child which has been trained in one of the best school and has not only just the knowledge of the books but also knows how to respond. But still, there is one problem. Now the one problem is alignment problem. So so the model knows how to respond. It has all the knowledge, but it does not have any human values. So the model knows, it has all the knowledge, it has all the value. So the model knows it has all the understanding, but it does not, and it also knows how to respond, but it does not have all the human values. So for that, there comes that alignment problem. Now, as far as the SFT model is concerned, for a given prompt like what are some effective ways to deal with stress, it can give you all the four kind of answers, which are all correct. But some of them are plausible or not helpful, some of them are helpful but impolite, and some of them are even harmful. So to overcome this problem, we have now the stage three, reward-based refinement, human feedback, learning from human feedback. So basically, it is a three-step loop of thousands and thousands of iterations, where the SFT model, generates the answers, and there is again rewarding model which actually has a grading of all the answers. And then all those answers are graded, and the ones which are more helpful and as per the moral values are rewarded more, and the ones which are, not appropriate are rewarded less. Then so basically, it's a generate, grade, and update, and then this proximal policy optimization mathematical reinforcement learning algorithm does the internal weight adjustment, and the cycle keeps on continuing for thousands of time, and we get a reward mechanism based on which the model now can have a more probable answers for the better answer. So after thousands of iterations, now the model have can answer which human prefers. So I want to pause here and want to give you a big picture of all the stages in word eye view. As you can see, it is a complete evaluation matrix, and finally, after the RL model, it is the one which is ready for deployment. So here comes the pathfinding problem for the model. Now it is ready for deployed and has almost, let's say, 50,000 probabilities of the question of the next word which it needs to select. So there are three approaches which it can take. One is a greedy search where it can just pick the most likely word, but it is boring and it would be repetitive. Next is multinomial sampling. It is like zigzag randomly select. And the last one is the top v nucleus sampling, which gives you best of both worlds. So it basically selects, highly, there is a small set of highly probable words, let's say, who are breaching more than 80% probability. And from that, it actually becomes creative based on the temperature and other things set. And then it gives you the most creative word based on that. So temperature is nothing but a probability distribution parameter, a mathematical parameter for the probability distribution. Between zero point 0.0 to 0.2, it's scored highly deterministic, predictable, and basically it wants to have the deterministic output. Next is zero point 0.5 to zero point 0.7. It is a balanced coherence and diversity. And this is mainly for chatbot responses, which are standard and conversational. Next is zero point 0.8 to 1.0, that is exploratory and less constrained. It is good for storytelling and writing. Next is 1.5 plus heating. It's a maths breakdown. Output becomes completely erratic and nonsensical, and it can be anything. It can give you any kind of output. Now here comes the AI report card. So there are two mechanisms like a good student, which gets marks. So here for AI also we have task performance and safety. For that we have multiple benchmarks for AI models performance. One is MMLU, massive multitasking understanding, grade school maths, human evaluation. And for the safety we have Toxigen, Truthful QA, and Privacy QA. So basically, if you see, it covers overall things like all the academics as well as if there is any privacy leakage, if there is any hate speech, abusive language. All these things are tested for the models. Next comes the deployed systems. So basically, when you talk about ChatGPT, it is not just that you are directly reaching to the LLM, which is the brain. There are proper, ecosystem where the user input first goes through the safety filter, where the input is properly filtered, whether it is proper and it does not contain any curse words, NSF to blue, and all the kind of steps. Next comes the prompt enhancer. In the prompt, so the prompt enhancer is basically where if you have any acronyms, any abbreviations, those are extended, and and if there is any incorrect spellings, those are corrected, and then it is passed to that LLM brain, we generate response based on a top P sampling which we just discussed, and then the output goes to the output evaluator. It doesn't go directly to the user output, and it checks for all kind of toxicity and data correctness and all, and then finally you get the output. So finally, the illusion of memory. So first of all, I would like to clarify that AI systems do not remember you. Every conversation starts from the fresh. So, how does this illusion of memory comes is that whatever you are typing, there is a context window. For example, in this case, we were talking about 4096 tokens. So a token is like it's not exactly like a KB or GB memory, but it's somewhere related to, in the LLM terms, it is the single unit of the words. So basically, in a plain sense, it's not exactly that. So basically, what actually happens is that whenever you are typing any question, those words are converted to green tokens. And then the session manager, what it does is whatever the history is available so far, it appends your last questions to this existing set of chat history, and then it gives you the brain. So for example, the first question was who directed Inception. It goes to session manager, and then let's say it responded with the Christopher Nolan. Then the second question, when the user asks, what else did he direct? So the session manager will append all of them and will give it to LLM brain, which would be like who directed Inspection, Christopher Nolan, and what else did he direct. But there is a limit. So nowadays, the big models have a good limit of 100,000 or maybe millions of tokens. But for a normal ones, when you are, because it is a costly affair. So, for example, let's say in our case, 5,000 tokens were there. So after the limit is breached, it tends to forget. So session management is nothing but token management of its capacity, and it's an entirely in itself is a completely different topic, which we can take up sometime else. So finally, I hope you understand the engineering behind, assembly line of uh, complete data filtering, getting the raw data, that stages of model of Babler student and professional, then positioning maths, how it is positioned, and the interference guardrails. And I hope I'm able to make you understand that, just when you just talk to a chat GPT, it is not just a request and response. There is a lot of maths, a lot of sweat and blood goes behind it, and you would have all now. I hope you understand what is the base model, what is the SFT model, what is RLHF model, and what are the guardrails around it, and what is the overall mechanism, how ChatGPT becomes so intelligent and how it is able to remember us. So I hope you like the video, and please share your feedback. Please like and subscribe the channel, and please put into the comments if you need any clarifications. Thank you.